We have been studying quadratic functions. We've been looking at how to simplify them, solve them, and also graph them. So this will be a summary of all those topics that we've been looking at in topic 2. So topic 2 overview, quadratic functions, our objective is to kind of tie these ideas together in a graphic. So first of all, with graphing quadratics, the first thing we did was we looked at standard form. And standard form of a quadratic was where we had y equals ax squared plus bx plus c. So that was our first topic that we looked at. So that ties to graphing quadratics. And we talked about what the axis of symmetry was with that. So we did axis of symmetry. And we abbreviated that AOS, and we made sure that we were able to find the axis of symmetry by using the A, B, and C. We knew that the x value at the vertex was opposite of B over 2A. Oftentimes we called that an H. We did the vertex as H comma K, but the x value is the opposite of B over 2A with that. So that was one of the major topics we were finding from that standard form. The vertex, like I just mentioned, was H comma K. The H was found by using that opposite of B over 2A, and then the K was found, the Y value at the vertex was found by substituting that back in or looking at your table on your graphing calculator to find that. And then we also looked at, see how the vertex was the X value there, and then we also found that the K value was the min or the max. And that's where we had Y equal to K. The min or the max value at the vertex. So the vertex tells us important information. It tells us the axis of symmetry. It also tells you what the min or max was. We also have been looking at the vertex form of a quadratic since the first topic. From when we were looking at chapter 1, we looked at what vertex form was. That was y equals a times the quantity x minus h, the quantity squared, plus k. Now from vertex form, you can go directly to the vertex. I mean, you have the h and the k right in the form itself, the opposite of what's in the parentheses, and the same number that's out there give you the x and y. And we have to remember that when we were doing this, we knew that if that a value in both of these, this a is the same value, if the a is positive, it opens up, and if a is negative, it opens down. And that ties into the min or max. If it opens up, it means we have a minimum. If it opens down, we have a maximum. All right, now just to tie this in, we'll get to solving quadratics in just a second, but just a reminder that in chapter 1, topic 1, we did a lot with graphing and we did a lot with our notation. So just a reminder from topic 1 review, things that you need to know for this. Okay, you need to know the interval notation. We've been using that all semester so far. So interval notation is where you have the parentheses or the brackets, depending on if you're including something or not. Okay, and then we also had domain or range, where we use this interval notation. So domain was what x values are being covered by the graph. The range is what y values are being covered by the graph. We also talked about when it's increasing and decreasing. So going from left to right, is the graph going up or is it going down? And then listing that in interval notation. And then also, where is the graph positive or where is the graph negative? And listing those are the y values when they're positive or negative, and then listing the x values, what range of x values are the y values negative, what range of x values are the y values positive. So it's just a little bit of review of things that we're tying into the graphing of quadratics that we've been doing all semester long. Let's go back up to our topics for this chapter, for this topic. Now for solving quadratics, we had 3 different techniques we used. We used completing the square, quadratic formula, and factoring. So completing the square ties to graphing because we used completing the square to both solve and to graph. So it's really one of those ideas that you can combine to both of these. We can do it for solving quadratics, and also we can tie completing the square to vertex form because we used completing the square to get things into vertex form. All right, we also had for solving quadratics, we had the quadratic formula. The quadratic formula you have to have memorized. I'm going to put down here x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and that formula, what we used for that one, we had that tied to how we did completing the square. You use completing the square to derive the quadratic formula. Okay, now you're going to use the a, b, and c in the standard form to solve an equation. And also we had solving quadratics, we had it tied to factoring as well. For simplifying, when we simplify things, we put things together using operations and using order of operations. Included in this, we want to think backwards, and factoring is backwards on simplifying. It means undo the things that we multiply and come up with factored form. So factoring, we had several different patterns that we used. We used ax plus b, x squared plus bx plus c. We had the form when the leading term was equal to 1. That's one of the simple techniques that we used, where we just look for 2 numbers that added together to give the b and multiplied to get the c. Now you can use other techniques to do this, but that's the quickest, simplest way to do it. We also had the difference of 2 squares pattern. We listed as m squared minus n squared. That pattern with m squared minus n squared, that's equal to m minus n, m plus n. So you take the square root of each and put a minus and a plus to get that factored. The third pattern that we use for factoring is where we do not have a 1 in front of the x squared. Instead, we have a number. So we'll have, instead, down here, we'll list ax squared plus bx plus c. You've got a number in front of that x squared. There's 2 techniques we used for that. We used the box method. That's where it was kind of an organized guess and check. You put the numbers in the box, you try it. If they work for the middle term to add up, then you've got the answer. If it doesn't work, you try a different one, but keep it organized. And the other technique we used was the X method. This was a method where you group things together using a technique. So you have to learn the strategy for it, and then you take that bx term in the middle and separate it into two parts and then group things in order to get the factorization. Each time you have to remember, I'm going to put it up here, make sure that you look for the GCF first. The greatest common factor is what you have to take care of first in all of these techniques. Take that out. That will save you time on factoring if you remove it first, and then you can do the other patterns for factoring. All right, and lastly for this, and that's where factoring is to undo the simplifications, to take things that were multiplied together, undo it, separate them into the factors that we started out with. All right, so let's take a look at, lastly, the complex numbers. Complex numbers involve imaginary numbers. And so when we do imaginary numbers, remember that the basis of imaginary numbers is where you're looking at when you have the square root of a negative. So that's where we have the square root of -1 is equal to I. We use that first. And then if you square that I, you get -1. So imaginary numbers are a new number system. When we combine it with real numbers, we get complex numbers. And you have to learn how to simplify complex numbers using the fact that you have to always take the I out if you have the square root of a negative, and then you can simplify things like if you have I squared, you can make it into a -1. So things we did with this is we did add complex numbers, we subtracted complex numbers, we multiplied complex numbers. This is where we did things like the double distributive if you have a complex number times another complex number, because complex numbers are in the form of a plus bi, so they look a lot like binomials. They are binomials, and so they follow some of those same rules when we multiply them. And then lastly, we divided complex numbers. And when we divide complex numbers, what that did is that looked like a fraction usually. And when you did the fraction, you had to make sure you got rid of, when you're simplifying, you want to make sure you don't have any i's in the denominator. So you want to eliminate I from the denominator. Of the fraction. Now that technique, oftentimes if it's a single term, you just multiply by I over I, which is equal, I over I is equal to 1, but that will change the form of it. Or you multiply, if it's a binomial, and a plus bi, you multiply by its conjugate, which is a minus bi, so the opposite operation in the middle. So in summary for this, what we did in this topic is, topic 2, is we looked at quadratics and the things that were involved with quadratics. We primarily simplified them, we solved them, and we graphed them. Some of these things tie together. Things like completing the square, we use to solve quadratics, and we also use to graph quadratics. But then other things, we learned a new number system, complex numbers, and how to work with those, simplifying them and using them in the solutions to things like quadratics. Like when we did the quadratic formula, if we got the discriminant here, so we could add right here that the discriminant classifies our solution. Just the b squared minus 4ac helps you to see what kind of solutions you have to the quadratic, whether they have imaginary parts to them, or if they're just real, if they're rational or irrational. So using all these, you can tie together. So with quadratics, You can simplify them, solve them, and graph them.